Welcome to the Fountain Dispensing System User Training Program. There are three main sections of the interface, namely Roadmap, Content Area and Navigation Bar. Roadmap. The roadmap guides the user through the different modules. Click on the module name to launch the contents. The navigation bar provides slides level controls. Content area. Content area presents the core content in the form of text, videos, and schematic diagrams. The video slides also provide a full screen option for the user to have an enlarged view of the content being presented. Search. Search button leads to the search window. Typing a word being searched for displays slides that includes the searched word or phrase. Clicking on any of the listed search item slides displays the contents. Welcome to the Fountain Dispensing System User Training. Upon completion of this course, you should be able to explain the constituents and types of post-mix fountain systems, explain how the post-mix system works, describe the main subsystems like water, filtration, carbonation, dispensing, and refrigeration. Explain the purpose and working of the key machine parts. Explain the machine operations, preventive maintenance, and sanitation. Describe the water and drink quality checks and settings. Handle machine troubleshooting. Let's look at the typical design of a post-mix dispenser. Carbon dioxide gas flows from CO2 tank to a regulator. Carbon dioxide is a tasteless, odorless substance. CO2 is used as a gas to carbonate water to enhance the taste of the beverage and operate the syrup pumps by providing pressure to run the components inside the pump. Regulators are used to reduce and control the flow of CO2 pressure in a post-mix system. Primary regulator regulates the CO2 tank pressure to maintain a constant 90 psi for the production of carbonated water. Secondary regulator regulates the CO2 or air pressure used to push the syrups to the dispensing valves. The Coca-Cola company uses a dual configuration regulator for most applications. Carbon dioxide gas flows from CO2 tank to a regulator and then flows to the carbonator tank at 90 psi pressure. A carbonator is used in all post-mix dispensing systems that manufacture carbonated beverages. It mixes carbon dioxide gas with water to create carbonated water. The carbonator is generally mounted with other backroom equipment, including syrup pumps and regulators. Water makes up over 80% of the beverage, so both the quality and quantity of water is important. The typical post-mix dispenser requires water volume of 100 gallons per hour to meet typical operating demands and maximize the efficiency of the dispenser. 40 to 75 psi of water pressure. A water source line at least ½ inch in diameter with a separate shutoff for the carbonator. Water regulator regulates the incoming water pressure to 55 psi, preventing flooding of the carbonator tank in locations with high water pressure. Water filter filters out both solid and suspended impurities found in the water supply, preventing damage to components, ensuring proper absorption of carbon dioxide into the water and a drink free of off taste. Plain water flows from the water source at a pressure of 40 to 75 psi to the carbonator. the CO2 and water mix together in the carbonator tank to form carbonated water. In post-mix systems, syrup is manufactured and supplied in 9 liters or 18 liters stainless steel containers, also called figgles. This syrup is mixed with carbonated water in a predetermined ratio, depending on the product flavor. All flavors of post-mix syrups have a best before date of 75 days from the date of manufacture. Diet Coke has a shorter shelf life, that of 60 days. Most systems use 60 psi of pressure to push the syrup to the dispenser. Make sure that the syrup pressure settings are proper at 60 psi for sugar-based syrups and 15 psi for diet syrups. Syrup pumps are used in pressurized systems to pull syrup from the bag-in box and push syrup to the dispenser. Syrup pumps operate using either CO2 or compressed air. The Coca-Cola Company uses pumps from 2 suppliers, SureFlow and FlowJet. Both the SureFlow and the FlowJet pumps have 3 connection ports. They are as follows: CO2 in to operate the pump, syrup in pulled in from the bag-in box, syrup out pumped out to the dispenser. Carbonated water and syrup go through the cooling system, where the temperature is reduced below 40 degrees Fahrenheit. When the valve is activated at the dispenser, 90 psi of CO2 pressure pushes carbonated water from carbonator to the dispenser. The process works as follows. Press the lever or touchpad to activate the process. Solenoid opens, allowing chilled syrup and water to flow into the dispensing valve. The syrup and water flow through the flow controls and out to the nozzle. The syrup and water mix together in the nozzle to form a finished drink. The licensed electric valve is the most common valve used in the Coca-Cola system. It is equipped with pressure compensating flow controls, one for syrup, one for water and one solenoid. It can be equipped with a lever, a push button or a portion control, that is push button or shuffle device. The LEV is available in 2 versions, a 3 ounce per second and a 4.5 ounce per second flow rate. Pressure compensating flow controls are used to regulate the flow of both water and syrup into the nozzle assembly. There is a separate flow control for water and for syrup. Each flow control is composed of a spring, a sleeve, a spool and an adjustment screw. The flow control provides a constant rate of syrup and water flow if water pressure stays within the 40 to 120 psi range. When electricity is applied, the solenoid attracts an armature which opens ports inside the valve, allowing water and syrup to flow into the nozzle. Change the figgle tank. If the figgle tank is empty, you hear CO2 gas escaping from the nozzle as carbonated water is dispensed when you press the lever or button. You can change an empty figgle tank by following these simple steps. Disconnect fittings by pushing them down, turning and then pulling them up. Remove the empty tank. Remove dust caps from connectors on new tank. Rinse fittings in warm water. CO2 syrup connectors are identified easily using color code, black for syrup and white for CO2. Connect 3 slots fitting to 3 pins connector. Connect 2 slots fitting to 2 pins connector. Operate dispensing valve to restore syrup flow.